Recordings are all uploaded to the YouTube channel. You can check, it's all there. So I just randomly pop them up and now they are there. And now you have notes also, all available in modules. Last time we did these properties, you guys told me I was writing too fast. You should let me know next time, just tell me I'm going too fast. But I wanted to finish, it's just like, teachers don't like to have like one line left before the end of the class. This is the shortcut or nice writing of whatever we did, so you don't have to copy that again. You'll have it in your notes. But basically we figure out adding functions, subtracting them, dividing them. You can do limits separately and it works fine. Now let's write down something about polynomials. Do you remember what polynomials are? There is a very nice convenient theorem, theorem, that if a function is a polynomial, who knows what polynomial is? Sometimes people say poly. Let's do polynomial. A polynomial function. Do you know what polynomial function is? Anyone? What is polynomials? Any example? Just example. Yes?
Sorry, 3x or y equals 3x cubed plus 2x squared plus 5x?
Yeah, definitely. Power of polynomials, x squared plus 5, x to the n in general, long or short, those called polynomials. So if a function is a polynomial or a rational function, rational, what do you think is that? Function. That is something connected to those two last properties, this one and this one. The first one is f of x to the n, that's a polynomial, and the other one is n's root of f of x, that's a rational function. So it has roots, square root, cubic root, and so on. Rational function, there are more examples of rational functions, but still. Then it's very convenient that you can just plug in. So there's a limit of the function f of x. As x approaches a, you don't have to perform anything complicated. You just plug in that a. If a is in the domain. If a is in the domain, that means f of a is defined. So it's not d and e, it's there. So this theorem is very important because it makes your life easier. And this is because polynomials and rational functions are continuous in their domain. Let's write down due to continuity. Okay. U-O-E-T. No, there's no O. Continuity. Like so. Due to continuity. Continuous function. Continuity. Looks good. Continuous functions, remember I just mentioned to you, not only if the idea that you put a pencil and a pencil on the graph of the function should go without breaking the pencil out of the paper. Functions are continuous if the limit exists from left and right, so the limit match, but they might be holes, so second condition is this hole should be filled in. Not only limit should exist, but f of x should match that number. That's what we call continuous functions. X squared plus 5, that is a parabola, it's continuous. X cubed, it's also continuous. In fact, I actually have a YouTube video of basic functions, which you're supposed to know. We can't expect you to remember how y equals x looks like, parabola x squared, how the cubic function looks like, absolute value, sine, cosine, right? So like you should kind of have imagination what these things are. Thus, as you can see, they're all continuous. So you can just plug the number in. And you're like, what does it even mean? Let's do some examples. And also, I always teach students with some neat steps, and they like it, so I keep doing it a lot. Steps. Steps are nice. When you freak out during the exam, you can remember my steps. We were also told not to teach you any kind of tricks. Like, you're supposed to be smart, you're supposed to be educated. Okay, I'm doing this because. But I also do understand that American exams are so short, they're only 15 minutes, that sometimes you freak out and you don't remember what is happening. If you just remember my steps, it works, and that's why students like it so much. Step 1, when you work with a limit, just plug in and see what is going to happen. That's exactly what we just said in this theorem. Sometimes you just plug in. Done.
So plug in the limit.
Yeah, plug in that number that we gave you. If it's 5, plug in 5. And I'll show you the example.
And this is steps for finding how to behave near the limit, right?
Yeah, the limit. Step 2. If something went wrong, if cannot, for example, you might have division by 0. That will be pretty popular mistake or idea. Or 0 over 0. Or something is happening. Then simplify. And this is where the algebra skills will be needed, and we reviewed them on the lecture 0. So what kind of simplification will be popular? The most popular will be factoring. We did factoring lecture 0, quadratic equation, remember? Full square. Sometimes you need to complete the square. Complete the square. Those kind of things. Then, if that did not work, multiply by the conjugate. That is where you work with roots. Multiply by the conjugate. And you don't remember what conjugate is, do you?
No.
So that's why I'm reminding this. Multiply by conjugate. You have a root. Say it was a root minus 7. Say square root minus 7. Multiplying by the conjugate means multiply by this root plus 7. But also don't forget to divide, because you cannot just multiply and pretend nothing happened. You can multiply and divide. So multiplying by the conjugate means the square root plus or minus the number, or even the other square root, depending on which one you're given. If you're given minus, multiply by plus, if plus by minus. Why? Because we will be using this formula, a minus b times a plus b, from lecture 0. Who remembers what is that? I reviewed it on Friday.
Wait, I'm a little confused. Is this for finding the limits of algebra?
Yeah, but it's right now, it's just algebraically, yes.
A squared minus b squared.
Thank you, good job. A squared minus b squared. So that's why we're going to be doing it. I'll show you the example right now, and you'll be like, oh, that's what she means. It's an algebraic part of finding the limit. Yeah, before that we did it graphically, and now we'll be doing algebra. And algebra sometimes have 4 or 5 steps. For example, multiplying by the conjugate. What else? If you work with trigonometric functions, then you should use trig identities. Some kind of trig identities. For example, the most popular one is, do you remember what sine square x plus cosine square x? It's 1. Good job. So this will be pretty useful. And then for the very first one, full square or factoring, it will be useful to remember quadratic formula, right? So ax squared plus bx plus c equals to 0, those things, and quadratic formula. So that is going to be important. And also important, a plus or minus b squared, the first plus or minus 2ab plus c squared. This one we also reviewed on Friday. So you will see we're going to be doing them right now, these things. Then when you finish that, something will cancel out. And then when you cancel out, you're done, you plug again. Plug again. If that did not work, repeat everything. So that is a very nice straightforward list of steps. Step 1, you first check if everything is fine. You plug in, maybe you are overthinking and everything is good. Probably you're not overthinking and the problem is not that easy. So then you have to simplify. You will see if there's a quadratic function there, you use quadratic formula. If you see a square root, you'll multiply by the conjugate, that's a long problem. And so on. Simplify, cancel out, plug again, you got the answer. Let me show you that it is that straightforward. The most popular problem students have is algebra. Somehow you guys just freak out sometimes and blank out, you know, especially during the exam, people blank out and they forget quadratic formula or something like this. So, example 1. What is the limit of x to the 4 minus 5x cubed plus x squared minus 7? Looks very bad. What is going on? When x approaches 2. You see, we worked with graphs for 2 classes. And now there's no graph. There's a weird random point x goes to 2. What is happening here? What is step 1 saying? Plug in, so we're going to just plug in 2. Moreover, this theorem I just claimed says polynomials are continuous. You don't have to be bothered. You just plug in. But my steps, they say plug in and see what's going to happen. If you got into some trouble, then you have to simplify. But if you didn't, then you're fine. 2 to the 4 minus 5 times 2 to the 3rd plus 2 squared minus 7, which is minus 27. Put it in the box, move on. Nice problem. That makes sense? Step 1, plug in, done, check mark. Example 2. So, limit. The moment you see a fraction, you know it's going to be a problem. Because dividing by 0 is a thing. And that is a troublemaker usually, which you need to get rid of. That's how I call it. It's a troublemaker. You need to figure out how to fix it. But in general, I told you the ratios are the one who are troublemakers because of the division by 0 and so on. Ratios are the most popular fractions we do in modeling of medical behaviors and, for example, vaccinations or even medicine like antibiotic. Ratios between these are all done in equations. So that is the most popular applications actually, is to have limit of ratio and derivative of ratio and integral of ratio. So we need to learn how to do this. But step 1 says plug in. So let's do that. When you plug in, let me do another color. I will have, so when you, pay attention what I just did in the previous one. The moment I plugged in, right, limit disappears. So that's what some of you need to get used to. Notation of the limit exists before you plug in. The moment right at the very end step, when you're calculating it, you should stop writing a limit. So get used to this notation. So I'm plugging in minus 3. So it's going to be minus 3 squared plus, let's do minus 3 minus 12 over what? 0. And that is not good. Like what is going to be divided by 0? We don't know. If you check a calculator, it will give you error. And yeah, that is not good. You know, there was a joke in Simpsons when the teacher was asking in class, okay, students, what is 2 times 6? 2 times 6. And all kids took calculators, started typing in. And then Milhouse was the first one. He says, low battery, low battery. And she was too tired to argue. She's like, yeah, that's correct. So don't write down error on the exam. You're supposed to actually do something about it. So we are not going to do that. Step 1 did not work. Well, we checked. So there's a troublemaker. We have to do what? Step 2. What does step 2 say? Saying simplify. So we're going to do step 2, simplify. And that is a very creative process here. First of all, see what I'm going to do. I'm going to rewrite limit again. And you have to keep writing it until you finally plugged in. And that's kind of a bummer, but you have to do that. You lose points on the exam if you don't do that. So you have to keep writing a limit until finally you plug it in. Because working with limits is not the same as working with functions. Function can be D and E at 5, but limit might exist at 5. So that's why. Well, any suggestions?
You simplify the denominator.
Numerator, how would you do it? Factor. Let's do factoring, full square, whatever you know. If you don't know, use quadratic equation. It always works. So who can tell me what numerator will look like?
X minus 4 and X plus 3.
X plus 3. Do you all agree? Anyone needs explanation? How did we get this? If you don't know how to do it fast, because I do know, most of us were taught the sum should be this, the product should be that, right? But if you don't know this, I always say, don't be scared. Schools are different. You can always write down x squared minus x minus 12 equals to 0 and find 2 roots using quadratic equation formula. x1 will be 4 and x2 will be minus 3, right, using quadratic formula. And now you can build this x minus root times x minus root. So just reviewing this. But I prefer to do it fast way because I know how to do it. Dividing by x plus 3. Now, this is the key idea. X plus 3 was a troublemaker in the denominator because we were plugging minus 3. and give us 0. This is our chance to get rid of the troublemaker, and that's the whole idea. But the tricky question, can we always cancel out things like this or not? Very interesting point. Do you remember maybe there were funny jokes, something like 4 times 0 over 3 times 0, cancel is 4/3, right? So can you do that? There's a whole idea that you cannot cancel out zeros, right? Because left-hand side is 0, but somehow I made it to be equal to 4/3. Because there's a theorem says do not cancel out zeros. You cannot divide by 0 even when you're canceling them out. However, I'm claiming that I can cancel out x plus 3, even though x is going to minus 3. Why? Any ideas? Yes.
Because we just have to acknowledge that x has no value at -3.
Well, that's a good point. So you can acknowledge that it cannot get into -3.
Because if it were, the problem doesn't solve itself. We just have to say, we just have to simplify and include the factor that it acts like this, except at -3 where it doesn't.
That is a good point. That's what you did in high school probably when we were solving some equations with denominators. We did that exactly. We are very close to what I'm going to say as well. Any more suggestions, ideas, comments? Why I claim I can cancel out x plus 3 even though we literally just got 0 there, a step before.
This is currently not a 0
Why?
because x can be anything.
Anything but then -3 too. You're very close. You're so close. Yes. Yes.
So has the limit sign out front?
And what does it mean? Like
Because
what?
we're going near -3, we're not
Yes.
going into it.
You're both correct. It's going very close to -3. And it's the whole idea of the limit. Remember I told you, this explosion over here. And I don't want to die, but I really want to know how this explosion is working out. What are the chemical reactions happening during the explosion or in the black hole? We've never been in the black hole. How come we have so many studies about it? Because the limit allows me to go as close as I want, staying alive, right? That's the idea. X is going to -3, but it's not necessary ever reach it. So let's put this as a note, and then we kind of keep it in mind in the future. We'll never kind of discuss it again. It's just an important thing to know. X is approaching -3, but not necessarily equals -3. So not necessarily equals. Since it's not equals -3, we can cancel out x plus 3 and x plus 3. Very interesting point. It approaches as close as we want, but it never reaches it. That's what it means to have limiting position. And that's why limits are so important. For you, it's just annoying homework right now, but actually it's that important. What is happening is populations of ticks on Earth in a century. That is a limit. We are looking into 100 years ahead. That's how we know it. We mathematically model and see what is limiting position tell us. Oh, it's going to be 1,000,005 of them, and so on. So that is how we can predict future as well using limits. And it's very interesting. So let me write down x minus 4 as x approaches -3. At the Salt Lake City, there is a very nice natural history museum, and there's a nice game there. If you go inside, there's a huge screens, and they have computers. They ask you to model and maintain Salt Lake City. So you start with 100K population, and then there's like news popping out, not enough water, not enough electricity, because populations keep growing exponentially. So at some point, we're all using limits to know how much water do we even need in Tempe in the next 10 years to cover all the population which is growing, specifically with ASU growing. We need food and water and electricity and internet. All of this is looking into the future. That's limit. So without going there, I'm approaching future as close as I can. That's kind of the big idea here. So we simplify it, and now we go to step 1. What was the step 1? Plug in again. Well, step 3, right? I'm plugging in. It's -3 and -4, which is -7. Done. Is this doable? Can you do it on the exam? That's what we put on a test, to be honest. So if you don't freak out too much, it's doable. But mostly you need to practice, and then your brain remembers what to do. Now, how about the roots? 3, the square root. Limits. Limit, is it 3? Yeah. Well, many people said they're fine with this example, but if you don't feel fine, you should kind of speak up. I always make this joke, did you blink? And now it's like written so much and you don't know what is happening. That is common, so let me know. Limit of a fraction square root of x minus 5, x minus 25, x approaching 25 equals. To be honest, the moment you see a square root, it's something about multiplying by the conjugate. Sounds scary, but it's always the same, and it's just a lot of careful writing of the roots. But let's do step 1. I'm plugging in 25. 25 gives me 0 in the denominator. That's not good. Moreover, it gives me 0 over 0. Do you see that? Square root of 25 is 5. I can even write down for you. It's 0 over 0. So the previous example, I actually never calculated the numerator. Was it 0 over 0?
Yeah.
Okay. So it was 0 over 0 here as well. That is not good, so we had to figure out something. Same here. We need to simplify. And you're like, I don't know how to simplify square roots. So multiplying by the conjugate works all the time. And this is how you do it. You copy the whole thing. Maybe take a different color or not, you decide. And then you multiply and divide by the conjugate, which is a square root of x plus 5, like so. That will give you the formula that will give you a formula a minus b times a plus b. See, square root minus 5, square root plus 5. Why this formula is neat? Because the answer is a squared minus b squared, so you get rid of the root. However, you cannot just multiply by thing and say that's the same stuff. If you multiply, you have to divide as well. But it's fine. Our goal is to get rid of the denominator because it's a troublemaker, remember? So let's see what is going to happen. Multiplying by the conjugate. Conjugate. Who wants to tell me what the numerator looks like? 25. What is happening at the top? Let me do some more people. Yes.
X minus 25.
X minus 25. That is very good, thank you. I will write down like so for students to have good notes. A squared minus b squared. Do you remember the formula? I mentioned over here. This is the formula. A minus b times a plus b, square of each with a minus. So that is why it's so convenient, because that's how you get rid of the square root, at least in the numerator. Denominators, though, looks ugly now. That is a concern, but maybe it will work out. Let's see. So the top looks like x minus 25. And you have it in a denominator. Moreover, that was a troublemaker. So that is not a coincidence. That is happening because you multiply by the conjugate. So we wanted this to happen. Now, since x only approaching 25, but actually never reaching it, we can cancel out by this. And we are ending up with completely new limit of, don't forget, it is 1 over a square root of x plus 5. Not 0 over and not just square root of x plus 5. So the numerator cancel out, but it means it has 1 there. So be careful with this. X approaches 25. Did we simplify enough? I don't know. So step 3, plug in and see what's happening. If it's not enough, you repeat something and do something more. But seems like it's good enough. When I'm plugging 25, what I'm gonna have? 10, yeah, 10 in the denominator, so it's 1 over 10. Can you do that on a test? I mean, the whole class is not just to prepare you for the exam, but I just always honest in my classes that this is what we put on a test. We like problems like this. We like telling students to factor and then to multiply by the conjugate. This is like 2 favorite problems we always put in this class and Calculus 1 class. What do you feel about that? Not too bad? Did you napped a little bit, or you actually like try not to fall asleep? I mean, yeah, try to stay awake. That's a good suggestion. Let's torture you a little bit with fractions on top of the fractions. I know that you guys don't like this. So let's do that. 4. Limit of 1 over, let me move it down a little bit. Move it down a little bit because it will take space. Go. Okay. I'll just put it here. Limit of 1 over x plus 6 minus 1 over 6 all over x. X is going to 0. For you to know, we can check all kind of limits, not only the one they gave us. We can check what's happening when x goes to 1, to minus 5, square root of 7.3. And those limits probably will give you some kind of number. But it's interesting to check the dangerous point. And the dangerous point there is 0 because when you plug in 0, you will get 0 over 0 case again. So step 1, I'm plugging in. And I'm having 0 over 0 case. When you plug 0, you have 1 over 6 minus 1 over 6 over 0. Then we're going to step 2, which means simplify. And this one doesn't really need to even, no factoring is needed. There's no quadratic roots. So my suggestion is always to say, if you see many tiny fractions, make it in one fraction and see what's going to happen. Always works. You have 3 fractions, make it 1. You have 1 fraction and a number, make it 1 fraction. Always works. So let's create 1 fraction in the numerator. In the numerator, yes. I will choose another color to make it more visual. So the x, like so. No. What is the common denominator? 6 multiplied by x plus 6. All agree? Yeah, common denominator is this. Then my notation, you all have different notations because different schools and countries. My notation, I put little bar and I put 6 here, and then x plus 6 here. You can have your own notation. That means I'm multiplying by the missing factor. Yes?
Wouldn't that make it the common factor, not the common denominator?
We call it common denominator.
Oh, we get the fraction.
Yeah.
I'm sorry.
No, good question, yeah. Man, good job. 6 times 1 is 6. Minus 1 times x plus 6 is x plus 6. This is not correct. Be very careful and put parentheses. If you don't put parentheses, you mess up. There's a whole meme about this. You're doing a whole long problem on the exam. Everything is correct. You miss parentheses, negative sign shows up, and then you fail. So be very careful with parentheses. The more you do math, the better. Now, this looks horrible, so maybe let's simplify more. You see, every time I keep writing limit up until I plug in 0. So that's the requirement. X is in denominator. Let's not simplify the denominator. Don't do anything here. Just, I like that 6 minus 6 is 0. So the top is minus x, right? Now what you're going to do. And this is what I reviewed in my lecture 0 because I knew that will be important. I reviewed this idea when I gave you lecture on Friday. How do you work with fraction over fraction over fraction over fraction? What do? You know? Multiply by the reciprocal. Good job. And very good terminology. So, I taught you last time that you can see it 2 ways in this case. This is a fraction which is also divided by x. You can see it this way. So x will go into denominator of this green fraction. Or you can see that you are multiplying x, you're multiplying by the reciprocal, which is 1 over x. So let me write down like this. Minus x over 6, x plus 6, divided by x. Do you agree, or it should be multiplied by x? 2 ways of seeing it. You have a pizza and you're slicing it first in 4 times. Slicing means dividing. So I'm dividing it by 4 pieces. And then more people show up. So you're dividing it also more by 2 each. That means 2 times 4. So whatever is in denominator should be multiplied by whatever was in the denominator. That's why x goes to the denominator. That's how I see it at least. Or multiplying by the reciprocal. No, yes, no, yes.
Wait a minute, this is only when you have 2 fractions. Okay, well, oh, never mind, no.
Right,
Never mind,
yeah.
that'll work. I was thinking through some basics, some very simple problems.
Yes. You have to process it a little bit. So good job. Keep trying and keep mentioning it. Now, can we cancel 0? X goes to 0. Yes, because it's not 0. It's just approaching there.
Negative.
Minus what? 1. Thank you. 6x plus 6. X approaches 0. All agree? Yes.
Top. It's like if you went like way more into like I guess, but like where did you get the negative x over the greater like after?
Yeah. Very good. I actually skipped it, and I was wondering if someone gonna ask. So this is 6 minus x minus 6. So like so, and then minus x. Yeah, I skipped that.
Sorry.
So I was curious if someone gonna have to know.
I thought you plugged into like the limit.
No, good question. Yeah. Always, especially that's exactly what I'm saying. When you blink, you like she wrote them.
Yeah. Thank you.
Now, can we plug in now? Step 3. Let's try. We simplified, and now we're going to have minus 1 over 0 plus 6 is 6. 6 times 6 is 36. That seems to be the answer. Why it's so ugly? 36. That took a while, so yeah, that's also one of the things sometimes. I don't like posting fractions over fractions on the exams because it's visually ugly and people freak out a lot. But still, you can see you can do it. Can you? Not too bad. I was like trying to find out how do you guys feel about all of this. People are like, I just want to go eat. It's almost lunch. Let us go. So let's see about this one. Oh, this is a good one. Example, completely new example. Example about continuity. Let's go back a little bit to piecewise functions, which are x squared minus 16 over x minus 4 when x is not 4, but then it's 8 when x is 4. You see, it makes sense. At 4, we have division by 0. So at 4, they decide to kind of relocate to another place. And they say, you know what, let's not divide by 0 ever again. So let's x not to be 4. If x is 4, just answer 8. It's like literally kind of cheating on the question. Instead of dividing by 0 and calculating, and they say, you know, just make it 8. That's fine. So question, is this function continuous at x equals 4 or not? That's it. Continuity had a definition. Definitions for continuity said we need to have a limit as x approaches 4 of this function f of x. And not only this limit should exist and should be equal to a finite number like pi or 3.7 or whatever it is, but this is not enough. It also should be equal f at 4. Then there will be no hole. No hole, so no jumps, no infinities are coming from the left-hand side, and then no holes are coming from the right-hand side of this definition. This is definition of continuity. This is something you're kind of supposed to remember. So that's what we need to check. We need to check if limit of f of x as x approaches 4 equals to f of 4. Okay. You know how I'm teaching piecewise functions. I want to kind of visualize them. So I will call equation number 1 and equation number 2. And I will make a diagram. Something is happening at 4. When x is 4, what equation are we using? 2, equation number 2, exactly. When x is not 4, which means on the left from 4 and on the right from 4, we're going to be using equation number 1 and equation number 1, which is a fraction. So let's see. Let's find the limit. So let's break it down into 2 steps. Step 1 without circle. Let's do step 1 with parentheses, and then step 2 is this. Let's see. Step 1. Let's find this limit of f of x as x approaches 4, which means x is approaching 4, but it is not 4. What function should I use? 1 or 2? Do you all understand that? That is actually a hard question, to be honest. If you understand it, that is pretty cool. I will visualize for you right now. X is approaching 4 from the left and from the right. That's what this limit means. But it never reaches 4. So we always stay at the function number 2, right? Function number 1. We never reach function number 2. That is pretty interesting. And actually, if you ask people outside of this class, just randomly, even calculus 2 or 3, they usually stuck at this. Like, wait, what is happening? So it's pretty good if you understand this part. But we are indeed using function number 1. Function number 1 is defined as this fraction, x squared minus 16 over x minus 4 as x approaches 4. So we chose function number 1. If you want to have good notes, we can write down because, BC means because x is approaching 4, but x is not 4. And since x is not 4, that is equation number 1. Let me put it in blue. 1. Does it make sense? Pretty cool idea here. And now it comes to whatever we just learned. I'm trying to plug 4. It will be 16 minus 16 over 4 minus 4. That's 0 over 0. That is not good. Step 1 did not work, which is very predictable, like how many times we're going to give you when it works. Honestly, never. We always wanted to do something extra. That's kind of the idea. So we need to do step 2. Step 2 says simplify. Who have idea how to simplify this?
Yes.
Difference of squares. Can anyone add comment on this? Yes.
X plus 4, x minus 4.
Yes, all agree? Good job. Difference of squares. Difference of squares formula. We just used it, but now we're using it in the other way. So it's going to be x minus 4 times x plus 4. Right? So it's the same we did with conjugate, but easier, and the other way around. X minus 4 in denominator. Since x is not 4, we even just mentioned that, we can cancel out, and it's literally simplified the whole thing into very simple x plus 4. You see, we're getting rid of the troublemaker in the denominator by canceling out. So it's going to be 4 plus 4, which is 8. That is interesting. Isn't that what we need? People are like, why she's excited? Because it's 8 over here. And that matters. If this will be a different number, the function is not continuous. But it matched. It's literally what it says here. We got 8, but f of 4 is also 8. So let me write this down nicely. Over here. So this was step 1. Step 2, f at 4 is, let me see, f at 4 is equation number 2. So I'm using equation number 2 in blue, and equation number 2 tells me it's 8. Thus, f of x is continuous because BC. That means because limit as x approaches 4, f of x gave me 8, and it's also defined at 4. That is the definition of continuous function. So this function is continuous. Basically, you should remember, if you get another number which is not the one you're given, then it's not continuous. Let me show you the graph. The graph looks like so. When we simplified this crazy fraction, x squared minus 16 over x minus 4, we got x plus 4 line. So if I want to draw this line, y equals x plus 4, it looks like so. This is the line we got. The only problem was that there's something happening at 4. Particularly at 4, there's a hole, and they say that at 4, please ignore the line and make sure it's 8. 8 is a number. But luckily, this 8 was on the graph. Because when you plug 4 plus 4, it gives you 8. So the hole was filled in. That is the idea here. There was a hole, but it was filled in either by you or by people who created this example or by a function representing genetic mutation of tumor explosion and so on. So that is a pretty cool idea that this is how f of x looks like. This function is continuous at 4 and actually everywhere else. When I put a pencil here, I can go to the whole function without taking it out of the paper. That is a pretty cool idea. What do you think about this? Yes.
If you didn't get 8, would this answer be it's not?
Discontinuous. Yeah, exactly. We can make a note about this right now. Yes.
Why would you plug in 4 instead of negative 4?
Let me see. Let me see. Oh, because they asked us only at 4. So they said check at 4, and this is what's happening at 4. So you plug whatever we ask you to plug. Make sense? If we ask at negative 4, we can plug at negative 4. It will be like over here somewhere, and so on. But
Negative 4 will be 0.
oh yeah, you're right. Negative 4 will be 0. So whatever we tell you, that's what you plug. If that's answers the question, yeah. And then note. Let's do the note which you just mentioned. What happens if it's not 4? Note, not 8. If limit of f of x would end up any number not 8, right? And 8 was already given. Then f of x is called discontinuous. Discontinuous. Usually people write discontinuous. Or not continuous, which means discontinuous. How do you feel about that? That is also in your homework, so you'll be doing this. And finally, last funny questions, series of questions. Example, what do you think is the limit of cosine x as x approaches 0? Because we never did any limits with tricks yet, like what the heck is going on here? 1, how did you get 1? You just plug it, it's still step 1, right? It's still step 1. You plug in, nothing bad happen. That is 1. So that's what I'm saying. Don't overthink it if it's not necessary. If there's a fraction, maybe you have to deal with something. But if it's not, it's fine. So what is a limit of, I don't know, e to the x squared plus 1 as x approaches 3? What is that? It looks new and you're like, we never did this in class. Yeah, still step 1. You plug in, what is going to happen? 10, right? It's 3 times 3 plus 1, which is 10. It's some kind of number. And so on. So just feel confident about these things. And the last thing I wanted to show you is this. We're actually doing really good here. So good job if you definitely understanding this. This one, last one. Limit as x approaches 1. X squared plus 3x minus 1, x minus 2. What is that? What do you think? Let's check. I don't know. 1 squared plus 3 minus 1 over 1 minus 2. Nothing bad happened. So it's going to be minus 3. So my point is, don't overthink if you don't have to overthink. Always check the step 1, and then, yes, you see some fractions, some factoring, you perform that. But other than that, limits, they also can be simple. So this is a positive note to end the week. See you Monday, have a good weekend. No.